All right, in this lecture, we're going to be talking about section 4.4, properties of logarithms. And we're going to add 4 more properties from our previous lesson. The first one being the product property. And it is, if I take some log of some random base of some function over another function, I can actually, oh, that's a division. Oh, got confused. Say function times another function. I can split this up as log base b of x plus log base b of y. So you got to be able to expand logarithms and condense logarithms, and then we'll use these applications to help us solve them. The next one is the quotient property. Oh. And it is log base b of x over y equals log base b of x minus log base b of y. Right? So basically, if I'm dividing two things, I can expand it by subtracting it. And then we will have the power property. And that's basically just stating if I have something random exponent, I can bring that exponent to the front and now make it a coefficient. Might help us be able to solve a function or two. And then the fourth one is what we call the change of base formula. It's pretty simple and used to help us solve since we cannot do too much in our calculators. This will come in handy in the future. So if we have something like this, log b of x, none of our properties help us reduce this. We can rewrite this as log of x over log of b, where the basis will just be 10. All right. With all that said, let's jump into our first objective. So in objective 1, we will apply the product, quotient, and power properties of logarithms. First one we'll look at is log base 7 of 49k. Right? So I'm going to first ask you to expand. So we'll expand to start, which means we'll use our properties to bring in addition and subtraction. When you condense, you use your properties to use multiplication and division. All right, but since I have 49 times k, that means that to expand this is the same thing as log base 7 of 49 plus log base 7 of k. Now, The issue is anytime you have a log with a number, they do want you to try to reduce this as best as you can. The best thing to do is see, can I turn this base into the base that I currently have? Meaning, can I make 49 be some multiple of 7? And hopefully you're saying, well, 49 is 7 squared. So therefore, I can rewrite this as log base 7 of 7 squared plus log base 7 of k. And from our previous video, if this base and this base is the same, then that is your answer. So I get 2 plus log base 7 of k. And that's how you would write that out. Let's look at another example. Let's look at log 24 VW. In this one here, I see that I have 24 times V times W. So that all means addition. So this becomes log 24 plus log V plus log of W. Now, again, we have a number here. Remember, there's no base there. It's an imaginary 10. Is there any way to make 24 be a multiple of 10? Hopefully you're saying no. If that's the case, then that is it. That's all you can do in that example. So let's start applying some division. So let's look at another example. So let's take log base 9 of m over n. So since I'm dividing, all I got to do is then turn that into subtraction. So that'd be log base 9 of m minus log base 9 of n. You do not have to use parentheses. I do it to clean it up, but if you just kept the parentheses off, you would be correct as well. All right, let's do another one. See if we do one more complicated. Let's look at log 1000 over c squared plus 1. Now, when you look at this, you're like, all right, this is a function divided by a function. So there's got to be subtraction in it, but then you're like, but there's addition. Does that mean I go to multiplication? No. This right here, we're expanding it. So you need to realize that this c squared plus 1 will be one term, right? It is together. So when we expand this, this becomes log of 1000 minus log, this is where parentheses will come into play, of c squared plus 1. All right. I cannot break that apart because of the plus sign. So that becomes one full term. All right. Let's look at objective 2. In objective 2, we're going to write a logarithm expression in expanded form. So a little bit more of what we were doing, but then put all together. So let's look at something like this. Let's look at log of 8, or log base 8 of a to the 4th over b to the 9th times c. Okay. So for starters, I look at this and I go, I have 3 terms, so I'm going to write log 3 times. So it's going to be log 8 of a 4th. I see a division bar, so I will subtract log 8 be 9. Since I'm still on the bottom of this fraction bar, instead of it being a plus for multiplication, it will remain subtraction because it's all being divided by. So this will tell me that this is being divided by this and this. If I was to write a plus sign, now I'm telling the reader it's this divided by this, whatever that result is, times this. And that's not what we want. The C is on bottom, so we want to show that that's all being on the bottom. Now, the other thing that you have to be able to do here is any exponent needs to be moved to the front to make it a coefficient. So your final answer here should be 4 log 8 of A minus 9 log 8 of B minus log 8 of C. All righty. Let's see what's another good one. Oh, here's a good one. Let's look at this example. Let's look at the natural log of the 5th root of E squared over C squared plus 5. All right, for starters, remember that a radical can turn into a rational exponent. So I'm going to rewrite this as E squared over C squared plus 5, all raised to the 1/5. So remember that 1/5 is the same thing as the 5th root. Now, the reason I would do that so that I can rewrite this as the exponent that now turns into a coefficient, and I'll put this in parentheses, and then I see that I have division. But once again, I have this plus sign. Remember, this right here will remain as one term. So I'll write this as natural log E squared minus natural log of C squared plus 5. Now, it's not quite done because I do have this exponent that needs to be moved to the front. This exponent will not. And it's because, again, it's attached to this plus 5. It cannot go any further. The other thing you need to see here is that the natural log of E from our properties in the last lecture is equal to 1. So this becomes 2 times 1, which will just be 2. So there's an imaginary E here. So when these are the same, that's my answer. And then I'll wrap it up here. I'm good with you staying at this point. Some books might have you distribute. So again, I'm good here. You might have to go a little bit further and say this is 2/5 minus 1/5 of natural log of C squared plus 5. I don't require that. I'm good at this point. All righty. So that's pretty good there. I don't think I can make that any trickier. So let's look at objective 3. Now we want to write this as a single logarithm. So we're going to basically call what I like to call condensing. Write a logarithmic expression as a single logarithm. All right, so let's look at our first example. We're going to take log of base 3 of 693 minus log 3 of 33 minus log 3 of 7. Okay. So we want to condense this. So anytime you write it as a single logarithm, you're just going to write log one time. The first term will always go on top. And the moment you see a subtraction bar, anything that has a subtraction will go on the bottom. If it does ever turn into a plus sign, then that term will go on top as well. So we have 693, and then we have 33 on the bottom times the 7 on the bottom. Now you're like, that's subtraction. That's supposed to be division. In this situation, this would indicate multiplication on the bottom of the fraction. All right, so when we do this, I end up getting log base 3 of 693 over, let's see if I can do this in my head. 7 times 3 is 21. 7 times 3 is 21. Bring over the 2, that'd be 23. And then 231 goes into 693. So 231, 462, 693. So this actually goes into it 3 times. And because this is the same as this, my answer is automatically 1. So that entire thing there actually equaled 1. I love when questions do that. Let's look at another example. Let's condense this guy. Let's take 15 log C minus 1/4 log D minus 3/4 log K. Okay, so again, single logarithm tells me I write log 1 time. Any coefficient will now become an exponent. All right, so this becomes C over 15. I see a minus sign, so instantly everything goes on bottom. Now I do get this D to the 1/4, and then I get times K to the 3/4. I'm going to be completely honest with you. On my test, if you get it to this point, you get full credit. On the homework, they want you to turn these rational exponents into radicals. So this becomes C to the 15th over, if 1/5 was the 5th root, 1/4 is considered the 4th root of D. And because this also has a 4th root, I can combine it as one big 4th root. I just got to make this a K to the 3rd. If you recall back in algebra, you learned that rational or algebra 2, sorry, is where rational exponents are E over I, exponent over index. So the top number will be my exponents, and the bottom number is the index of the radical. So this is what they want you to do on your homework. All right, let's do an even more complicated one. See if I can fool you on this one. So I get 1/4 log 2 of W plus log 2 of W squared minus 100 minus log 2 of W plus 10. All right, here we go. Single logarithm tells me I write log 1 time, so log base 2. All exponent or coefficients become exponents. That's the only one I see. So far, I know that this is going to be the 4th root of W. Go ahead and convert it. If you have to write out W to the 1/4 and then the 4th root, that's fine. I then get a multiplication sign, and I see that I have W squared minus 100. And then I have a division sign, W plus 10. Now this one becomes pretty good. And you're like, all right, that seems about as far as I can go. However, the homework expects you to notice that this guy right here is a difference of squares. So this gives you the 4th root of W times W minus 10 times W plus 10. Right, so that's a difference of squares, all divided by W plus 10. And then they want you to cancel out that so that your final answer ends up being log base 2 of the 4th root of W times W minus 10. So that one's a pretty good doozy. And technically, all of this would be in parentheses. I think I'd be pretty stoked if you got to this point. I might take maybe a point off for not reducing all the way, but you would definitely get majority. All right. So now let's talk about that change of base formula. So if I give you something like this, log base b of 12, not change the base formula yet, but I give you this information. If I tell you, right, given, there we go, that log base b of 2 is approximately 0.356. Log base b of 3 is approximately 0.565. And log base b of 5 is approximately 0.827. The way we have to do this is we need to break this number so that it's multiples of 2, 3, or 5. And so when I'm looking at 12, I instantly think, well, that's 4 times 3. 4 is not one of the numbers, so I need to break 4 further and see that's 2 times 2. So I got to see that this is the same thing as log base 2 of 2 squared, since I have 2 of them, times 3. That's what 12 would equal. And then I got to expand that. Now I got to write this as log base b of 2 squared plus log base b of 3. And we know that exponents become coefficients. So this becomes 2 log base b of 2 plus log base b of 3. So now that's where these guys come into play. I then backfill those answers in. So that becomes 2 times log base b of 2, which is 0.356, plus log base b of 3, which is 0.565. Alrighty. I don't really have a calculator with me. But if you add all these up, that will give you 1.277. All right. So let's talk about the last objective. Objective 4. Apply the change of base formula. So we're going to do a few things. We're going to estimate what the numbers are between. Kind of like what we did in the previous section. Then we'll use the change of base to plug into our calculator. And then rewrite as a exponential. All right, so here we go. So if I give you log base 8 of 5, if you rewrite this as an exponential, this becomes 8 to the y, that's a 4. 8 to the y equals 5. Ask yourself, 8 to what power would give me something like 5? Well, start with 0. 8 to the 0 is 1, but 8 to the 1 is 8. 5 falls between 1 and 8. So our answer for part A would mean that our value has to be somewhere between 0 and 1. After that, in part 2, or part B, to use the change of base formula, I'm going to type in my calculator log of 5 over log of 8. Now, this comes in handy for y'all more than it did in pre-cal because I cannot type log base 8 of 5 into those calculators. I have to use the change of base formula to be able to say log base 5 over log base 8 because our calculators only have log base 10. If you type this correctly in your calculator, though, you will approximately get 0.774. And then on part C, if you have to rewrite this, now that I have this answer, it would look just like this, but now I'd plug in 0.774 in for my Y, and I should get about 5. Right? And that's it. I do not think I have anything else in this. I think you'll be fully prepared for the homework. When we come back on Monday, we'll look at 4-5. And then go from there. I think we got 4-5 and 4-6, and I think that might be pretty much it. Enjoy y'all's trip. If y'all need any help, please text me, email me, whatever you need.